depends upon the male to female. So if we talk about the female, that is a 4.5 million, and if we talk about the male, that is a 5 million. This is a, we can say, a normal range of RBC. It depends upon the female or the male. In female, that is a 4.5 million, and in the male it's 5 million. After that, erythropoietin. Now what is erythropoietin? Basically, erythropoietin is a glycoprotein hormone. It is a glycoprotein hormone that is released by kidney. It is released by kidney. Now what is the work of erythropoietin? Basically, erythropoietin is a hormone. It helps in the RBC formation. It basically initiate the process of erythropoiesis. Now what is erythropoiesis? Basically, erythropoiesis is a, we can say, a process in which the RBCs are formed. That formation of RBC by the process that called the erythropoiesis. So basically, erythropoietin is a glycoprotein hormone that is released by kidney that help in the formation of the RBC, which means it initiate the process of erythropoiesis. Erythropoietin, glycoprotein hormone, it initiate, or we can say it proceed the process of the erythropoiesis. Now here is one important, we can say, point, that as I discussed here, in mature RBC, nucleus and mitochondria got disappear, but there is one, we can say, mammal in which nucleus and mitochondria did not disappear even when they are mature. The name of mammal is camel. In camel, the nucleus and mitochondria both did not get disappear. This is the only animal in which the nucleus did not get disappear when even they are mature. Now if we talk about the RBC, in RBC 95% cytoplasm is present. In 95% cytoplasm is present, that is covered by hemoglobin, and 5% enzymes are present, and some salts are also present. 5% enzymes and salts are also present in this. Now if we talk about when the one RBC got breakdown, we can say RBC breakdown, then what we get from the RBC breakdown. So from that, first thing we get, that is a hemosiderin, in which the iron what is hemosiderin? Hemosiderin is basically the iron storage complex. In this, iron is stored. Iron storage complex. It is iron storage complex. Number one is hemosiderin. Number two that we get, that is a bilirubin. As we all know, what is bilirubin? It is a yellow pigment. Bilirubin. And number third we get, that is a biliverdin. These are the three things that we get after the breakdown of the RBC. Now if amount of bilirubin got increased, then what will happen? If the amount of bilirubin got increased, then one disease can occur, that is called jaundice. It is, we can say, caused if the bilirubin, if we can say the amount of bilirubin got increased, then the jaundice can occur. Basically this is a disease, as I told. Now if we talk about the one RBC, in one RBC, basically the 200 to 280 molecules of hemoglobin are present. 280 molecules of hemoglobin are present. Now here 12 to 16 gram ml of blood, we can say in blood total, if we talk about, or we can say normal, 12 to 16 gram ml of hemoglobin count is present in the blood. If we talk about this is HB count in the blood. Now in 1 HB, 4 O2 are present, and in 1 gram of HB, in 1 gram, here we have talked about the 1 HB, here 1 gram of HB, basically 1.34 ml of O2 is present. In 1 gram of HB, 1.34 ml of O2 is present, and in 1 HB, 4 O2 are present. After that, if we talk about here HB plus O2, when HB is attached with O2, then what will happen? If HB is attached with O2, it will make oxyhemoglobin. It will make oxyhemoglobin. If HB is attached with CO2, then what will happen? That will make aminoglobin. After that, if HB is attached with carbon monoxide, then what will happen? That will be make carboxylic hemoglobin. It will make carboxylic hemoglobin. Basically, in these three, if we talk about which have higher, we can say, ability to attach with hemoglobin, so that is the carbon monoxide. It has, we can say, more ability to attach with HB, even 3 times more than O2, 3 times more than O2. It has 3 times more than from O2. It has more ability to attach with the HB. After that, we are having one enzyme that called the carbonic anhydrase. Yeah, carbonic anhydrase, that basically that supply O2 to the RBC. That is a carbonic anhydrase that supply O2 supply. After that, before birth, where the formation of RBC occur. Before birth, where the formation of RBC occur, it occurs in the liver. Before birth, or we can say that in the fertile stage, where the RBC formation occur, that is in the liver. And after birth, that will occur in the red bone marrow. Yeah, after it will occur in the red bone marrow. Yeah. After that, as we've discussed about the erythropoietin, we can say initiate the process of erythropoiesis. It is a process when oxygen get low in. We can say erythropoiesis also occur if the oxygen get, we can say, reduce, or the amount of oxygen get low during, we can say, it usually get low during the exercise. So the erythropoiesis will, we can say, erythropoietin will initiate the erythropoiesis, then it will release more RBC that is needed. After that, if an abnormal increase in RB count, abnormal increase in RBC count, then what will happen? That will occur the polycythemia. Polycythemia. It is a disease occur when the abnormal increase of RBC got. After that, if RBC count decrease, then what will happen? Then erythrocytopenia. Erythrocytopenia will occur. Cytopenia will occur when it will decrease. When it will increase, it will occur polycythemia. When it will decrease, it will be erythrocytopenia. After that, when RBC breakdown, there's a one point that when the RBC breakdown, the HB also complete. As we talk about, HBs are present in the RBC. So when RBC got breakdown, HB also got breakdown completely. Now cell membrane of RBC is made up of the phospholipid. cell membrane. RBC made up of the phospholipid. Yes, it is made up of the phospholipid.